Hello class! Today we are talking about axiomatic systems. What does that mean? Geometry is an axiomatic system. What that means, quite simply, is that there are rules that must always be followed. That's all an axiom is. It's a rule. There's a rule that has to be followed. So we call it an axiomatic system. All right? For example, this is taxicab geometry. It's like a taxi cab. If I wanted to go, for example, from one point to another, right? Generally, we would just draw a straight line. But if we're looking at taxi cab geometry, if I want to go from the Methodist Church to Brookshire's, the people over there at the Harvest are going to be a little bit annoyed at me for driving my car straight through their restaurant, right? Or if I then want to go from Brookshire's to Becky's Drapes right there, that's going to kind of take off everybody as I plow through the funeral home. That's no good because there are rules that have to be followed. You have to follow the road, right? And in taxicab geometry, which is very useful for real life because you have to follow the rules, these are rules that have to always be followed, it's an axiomatic system. What we're going to deal with is Euclidean geometry, which also has rules we have to follow. A little bit different though. We don't have rows. There's no grids, right? Just all Euclidean geometry means is we've got a blank sheet of paper. That's it. Blank, flat surface. All right? Now, we've got two different kinds of rules. We have the postulates, and these are what we refer to as the axioms. These are the postulates. All right? And we also have theorems. Two different things. Now, the postulates, these always work, but they have no formal proof. These are considered to just be self-evident. All right, we hold these truths to be self-evident, which means that you shouldn't really need a rule for that. All right, theorems, these are a bit more complicated. All right, these are things that are proven to work. We know they work. We use these postulates and these definitions and these other theorems to prove that these things work. Okay, postulates on the other hand, what's it? Self-evident, super simple. Duh. Right. For example, the Ruler Postulate. Points on a line can be paired with real numbers, and distance between the 2 points can be found by finding the absolute value of the difference between the numbers. Okay, that's lots of math talk. Great. What does that mean? What that means is I can do this. Yeah, that's right. I can make a number line, and I can put points on the number line. Everybody knows that, right? You've been looking at stuff like this since, I don't know, kindergarten or something, right? And you want to know the distance between point L and point R, well, you just subtract the two, and that gives you the distance, absolute values. So, super simple stuff you've been doing since elementary. We've got a postulate. This is a rule that says you're allowed to do it. And does anybody question that? No, that's pretty obvious. So, like I said, self-evident. We don't have an actual formal proof for it, but it always works. And because it always works, and you've been doing it for so long, I would like you to really quickly solve these 5 questions. And I know you say, wait a second, Ln, what is Ln? There's no symbols above it, right? We talked about if it's got a line above it, it's a line. If it doesn't have any arrows, it's a segment. If it's only got one arrow, it's an array. What is this? There's no symbol. All right. If there's no symbol, what that means is I want the distance from L to N. So how far is it from L to N? Another way to think about this is to know how long is segment Ln. Okay, so if there's no symbol up above these, that means we are looking at distance. All right, so if you could real quickly do these first 5 questions, pause the video, and then come back and check your work. All right, you're back. Let's see what were our answers here. Hopefully that's what you got for your answers. Now some of you thinking, wait, I got those numbers, but mine are negative. Remember, it says it wants the absolute value, right? Distance is always positive. So here, I did this from P to M. P is right there at negative 4.5. M is at negative 3. So I did negative 3 minus negative 4.5, which is a positive 1.5, right? Because you subtract a negative is adding. So positive number. For L to N, L is at negative 1, N is at positive 5.5. So I did positive 5.5 minus negative 1. Subtract a negative is a positive. So 5.5 plus 1 is 6.5. Our M, however, so from 0.5 down here to is negative 3. So that would be negative 3 minus positive 0.5. Well, that's negative 3.5, but we want the absolute value, which take a negative, you make it positive. If it was already positive, it stays positive. Same thing over here with SL. From 3 down to negative 1, so negative 1 minus 3 is negative 4, but we want the absolute value, which makes it a positive 4. Now, some of you work these out and you have these numbers in the opposite order, right? So 3 minus negative 1, or 3 minus negative 1 is positive 4, all right? It's fine. That's why we do the absolute value. It doesn't matter what order you do it in, your answer is always positive. Distance is always positive. Point right now, point to a place that is negative 5 feet away from where you're sitting. Yeah, you can't do it. There's no such thing as negative 5 feet away. You'd have 5 feet behind you, 5 feet in front of you, 5 feet above you, 5 feet to the left, but it's still 5 feet away. Distance is always positive. Next one down here, number 5. How many points are there between R and N? Now, some of you said just 1 point, S, right? Some say, well, no, wait, there's more points. Look at all these other points that are marked. 1, 1.5, 2, 2.5, and so on. The exact answer is infinitely many points. Because, yes, we do have 1 and 1.5, and those are marked. But we also have 1.51. It's still there, right? And 1.512. And 1.5123890015398, right? Infinite number of points just between 1.5 and 2. So there's an infinite number of points between R and N. Right? They're not all going to be marked because nobody has a magnifying glass that is that good to show all of them. But they are all there. Okay? Alright. Another postulate we're going to look at, which you can say, like, duh, is the segment addition postulate. We're actually going to use this a lot in class. It says if point B is between point A and C, remember if it's between something, that means it's on the line, so they're all collinear, then the length, right, no symbol above it, so length of AB plus the length of BC equals the length of AC. So if I know how long this piece is, and I know how long this piece is, I can add the two pieces up to get the length of the whole thing. Duh, of course. That's why this is a postulate. That's why this is something we do not need to have a formal proof for, and we accept this as being self-evident. Okay, this is one of those axioms. It's a postulate. We don't need to prove it. All right, so real quickly, we're going to do a couple of examples with this just because we like easy stuff. So here we go. If you would pause the video, work these 3 questions out, then come back and check your answers. Alright, so let's see how you did. Hopefully this is what you got. If that's what you got, then good job. You're awesome. If not, then let's figure out why. Okay, so the first one. AB equals 3, BC equals 7. We want the length of AC, right? So we know by our segment addition postulate, we can take AB plus BC, and that's going to give us AC. So we plug in 3 for AB, 7 for BC, and 3 plus 7 equals 10. So AC equals 10. That one's simple. Slightly more complicated here. AC is 45, BC is 28, we want AB. So it gives us the whole thing. We still have the same basic equation, right? AB plus BC equals AC. Plug in the 45, plug in the 28. So what we do, we subtract the 28 from both sides, and 45 minus 28 is 17. A little bit more complicated on number 3, because here they're giving you expressions with x and stuff. But it starts the same way. AB plus BC equals AC. All right, so 3x plus 5 plus 2x plus 8 equals 88. Alright, so nothing to distribute into the parentheses, so the parentheses don't mean anything, and we can just combine like terms. So 3x plus 2x is 5x, 5 plus 8 is 13. Subtract the 13 from both sides, 5x is 75, and so x equals 15. Alright, pretty easy stuff, right? Pretty basic. You say that we have a rule that says we can do that, that's obvious. Yeah, it's obvious. That's why we don't have to prove it, and that's why it's a postulate and not a theorem. We'll be getting into the theorems later on things that are complicated and have to be actually proven. So this is segment addition postulate, the Ruler postulate, which is pretty duh. Theorems have to be proven, postulates don't have to be proven, and it is an axiomatic system, which means it has to follow the rules. And that's that. Hope you found that useful, and I'll see you in the next video.